So I think the first area we just want to talk through as we talk about the rapid development of IoT systems is maybe to talk a little bit about the the life cycles that customers kind of walk through when they as they build systems. So this particular timeline here shows the product development process all the way from concept up to end of life, and there are many stages along the way, and these are going to vary a lot from there isn't one size fits all model for this. So I'm kind of showing here an example of you start off with a concept, you move to prototype, there's maybe some initial testing you do, followed by a more extensive validation of the concept, where then you move to a pilot phase, and with maybe giving customers access, and then finally scale for production before moving, after the new product is released, into a life cycle management mode. And then at some point down the road that you're going to reach, the product will reach end of life, right? It'll have to be taken out of deployment. So as you move from left to right across this, a few of the major things that kind of come out of this is that the engineering process and the deployment process and all of the marketing and every aspect that goes into this product development is all aimed at reducing risk, right? So at the left-hand side here, you've got some general ideas with a lot of unknowns and potentially a lot of risk with the development. As you move from left to right, you seek to reduce that risk and improve the accuracy of the product itself and also the confidence in the outcomes. Okay. So, and one of the key things that we've learned is we've sort of talked to customers about, the difficulties they have with doing system development these days, is that really what customers want is a seamless progression from product concept to scale and beyond, right? They want to focus on adding their value and not making, our vendor solutions work, right? Whether it's, from a single vendor or multiple vendors, which is more typically in the industry, the customers are, integrating elements of solutions from different vendors to make a complete system work. They don't want to be spending an awful lot of time doing this. They just want things to a large extent to work out of the box. Customers are increasingly becoming system integrators. Again, the sophistication and scale of technology these days that are going into these systems are so vast that customers, can't be spending a lot of time learning about, all of the nuances of how you put, full signal chains together. They'd like to have sort of solutions that they can take off the shelf, maybe with some tweaks, and just kind of integrate them together into a final product. Customers are seeking to minimize risk, especially at these transitions. I mean, there's certainly key transitions as you move from maybe prototyping, or through validation into pilot, into scaling, where there are various aspects of the program may dictate redesigns if you're not careful, and customers are really anxious to manage risks around these transitions. Okay, you want to maximize reuse from prototype all the way to production. So if you start doing some early software development, ideally you'd like to be able to keep that intact and not have to redo that or rebuild that later at a later point. As you move on these various phases from prototype into production. And then finally, you really want to improve the time to prototype or minimal viable product, and then to scale, right? And the tools that they must really be easy to use and enable the end product to be easy to use, which is a key thing as well. So as we think about the different concepts here, right, there are different ways that we as vendors can make it easy for customers to to integrate and to start building systems early. So for example, using tools that there are a lot of tools that we use, for example, from companies like MathWorks, from National Instruments, and we have some homegrown tools ourselves, and talking to cloud platforms such as ThingWorx in this case. But the whole idea is that as a customer starts to think about concepts and product concepts, they'll typically may start with some kind of simulation tool or simulation modeling tool or system modeling tool. And ideally at this point you'd like to be able to enable them to actually also start talking to their cloud platform of choice, right? So you can start to virtually build a system to test some basic ideas around a concept at very early stages. This kind of allows you to learn an awful lot about what you're trying to build before you actually start committing to developing hardware. The next stage then would be to look at certainly the prototype development, right? And here what's incredibly helpful for customers is a range of different development kits as well as the cloud platform. So we're showing a variety of different kits here. There are lots of tools out there. The likes of Arduino and Raspberry Pi are proving more popular these days. But these are tools that enable it, make it really easy for customers to get their systems up and running. So examples of some of the things that are helpful here are microcontrollers, typically connected microcontrollers or DSPs, and then perhaps a range of different plug-in sensors and measurement systems that kind of will, if they're not exactly representing what a customer is trying to do in their system, will get them pretty close so they can kind of, move into, a basic prototype stage and for validation. So examples of sort of connection standards that are out there today are, for example, a lot of vendors are building Arduino compatible kits or Raspberry Pi compatible kits. Some of the folks that we work with use the PMOD connectors, which are pretty common, for some of the higher end development platforms. But overall, the ability to kind of plug and play different sensing systems together with minimal software effort to allow you to build a connected sensing system, even if it's not cost optimized, is something that can be enabled by development kits and also reference designs and stuff for measurement systems. And it's important that these kind of are targeted for IoT as well, so there always has to be a connectivity element of this as well to allow customers to be able to start prototyping and actually maybe even start to validate this with some early field tests. Okay. And then as you move to pilot and scaling, for production, at this point is now where you have to start thinking about more seriously about form factor and cost, right? So typically in pilots, you're trying to build a system that's very representative of what the final product would look like. So in this case, if your final product is maybe going to be a wearable device or something that has to fit in a very, very small form factor and run off a battery or potentially energy harvested, the pilot devices need to be able to support this at this point, so you can actually really test the idea in the field, right? And as you move to scale, then you may have to design a custom solution. But in many cases these days, especially in the range of communications type devices, like for example Bluetooth or Wi-Fi radios, or even the newer sub-gigahertz standards, for example 6-LoWPAN type devices, or network protocols that are based on 6-LoWPAN. Increasingly, customers would like to buy just communications modules that are already pre-certified, right? Either for the likes of the RF certifications that are needed, but also that are certified to interoperate with other devices of the same protocol. Okay, and this sometimes customers will be able to go to market with these kind of pre-built modules from vendors, and then once they hit the right level of production scaling that can justify a custom design, they may choose to redesign the more cost-optimized versions of the modules themselves at that point. In all cases here, again, we're showing that these devices should build on the protocols, the connectivity protocols and the application layer protocols that were established on some of the previous stages here. So the idea is that if you're using HTTP REST to connect to the cloud, or MQTT, for example, that as we've gone through these various stages, that should not have changed, right? So you don't have to reinvent that every time, regardless of what hardware platform or even virtual simulation platform you're running on, that you would be supporting the same connectivity protocol, or application level protocol all the way through this. So as I kind of just move on here, I mean, one of the things that's worth considering for a moment are some of the top obstacles to IoT adoption, right? So, and the digital transformation. So here's an example of some surveys that were done a few years back, through either Cisco, Forrester Research, and also IDC, that kind of like identify the top obstacles, right? So probably the biggest one and the most concerning is security. Right, no real surprise there. That it's a real, making sure that systems are secure is a a very large aspect of anybody, and a very high risk, I would say, or risk associated with building IoT systems. But not too far behind is the question of addressing the whole question of complex integration, right? So this goes back to the point I mentioned earlier about customers having to integrate systems from many different vendors, right? Obviously, customers are always going to want to try and use the best that they can get, at the price that they, that support the price point of their final product. And this often means going to multiple vendors, and so the question of complex integration is a real, important part of this. Other areas as well, and these kind of maybe touch on the smart sensing aspect we talked about earlier. The need to automate the extraction of insights and actions, right? And also the concern about data overload. That in many cases there's a lot of data that would get sent to the cloud that is simply just not used. Right, and so the ability to manage this, and also to automate the process of extracting insights, is one key enabler, and a challenge, I guess I would say, for a lot of IoT systems and system developers today. Okay, so as we think about the area of enabling this information journey. So we talked about this earlier, this kind of loop or value loop that we talk about. There are several different ways in which that are technologies that need to be brought to bear, right? So again, moving around the loop here, we've got an action happening in the real world, in this case towards the bottom. You sense that action, you maybe make some measurements off that, you interpret that measurements or those measurements, connect it to a cloud, or whether on-premises or off-premises, where cloud gives you the ability to start doing more detailed and in-depth analysis and prediction, and followed by feedback that allows you to modify actions or behaviors that are happening in the real world. So one of the key elements, as we talked about earlier, is enhanced edge sensing and measurement capability, right? So key, good quality measurements are always going to be important to building a good quality and extracting high quality information and insights from a system. Security, as I mentioned, but haven't really dived into too much detail on this webinar. Security is another area which is key. The ability to be able to ensure that the data that you're looking at and the information and insights that you're looking at are coming from known sensors and that have not been tampered with, and that information has been communicated securely all the way around the loop here, right? So you have a trusted sensor, and you know that the data is kind of has not been modified or changed or spoofed in any way as you move around the loop here. I mentioned that the algorithms and analytics, machine learning are very, very key parts of this. The ability to sort of have algorithms that are either on the edge node themselves or out towards even embedded into the sensors themselves to enhance the measurement and interpretation capabilities of these devices. And then, maybe running on gateway or clouds, the ability to run analytics. There is an increasing trend, as I've talked earlier, about trying to push this capability closer to the edge, so the actions taken or insights gained can be more immediate. And then, also, applying advanced concepts such as machine learning really allows us to move into the kind of the prescriptive and predictive space of trying to anticipate what a system is going to do, and essentially being able to take action before anything ever goes wrong effectively in the real world. And then finally, I talked a little bit about accelerating customer IoT development and ultimately deployment. I mean, able to support customers as they move through the entire development process, all the way from initial concept all the way to deployment in the field and production, and also even to end of life. So the ability to be permanently disable devices remotely when the product is no longer being used. And so, a couple of other areas here as well. There's many different technologies that actually come into bear here, and are really, really important. I mean, one of the key things is that one company has all the technology capabilities to be able to do this alone, right? So partnerships and forming partnerships with companies is a key piece of this, and so it's very clear that partner networks and consortia of various kinds are part and parcel with this whole IoT rollout that we're seeing today. Algorithm development is key, right? There are lots of different types of algorithms that basically these are the key to being able to gain greater insights and provide more value for our customers. A range of different hardware and software solutions that sort of target different sort of capabilities and power profiles and form factor profiles, and using this hardware and software in such a way that customers can very quickly develop prototypes and get initial testing and validation of a concept running, but then the ability to take the hardware building blocks that are part of development kits and very quickly scale those either through modules, whether it's communications or applications modules, using hardware and being able to take hardware and leverage it to very quickly build a cost-optimized system, and having all of the tools available to support that is also a very important part of these IoT deployments. And then we've talked a little bit about the customer applications, whether it's building out the variety of different applications like automotive, healthcare, smart industry, manufacturing, communications, etc. And the ability to make it very easy for customers to actually build their cloud applications and mobile apps as well, based on tools that vendors supply, is also a key part in this IoT development and information journey.